Polar form of a complex number. Complex numbers are two-dimensional numbers defined by a horizontal real axis and a vertical imaginary axis. Your real axis is the old number line with real numbers, and then we have a new imaginary axis which is perpendicular to the real axis, which has imaginary numbers I, 2i, and so on. Now, if you have a complex number, say a plus bi, so every point in this complex plane represents a number. So if this is a complex number, that is at a distance of a to the right and b up. So a to the right and b above. Then this is a complex number a plus bi. This is called the rectangular form of complex number if you are using the perpendicular axis, real axis and imaginary axis. Now there's one other way to represent the same number, a plus bi. This time we use the distance from the origin. Let's say this is r, and the angle it makes with the positive real axis, let's call it theta. So if you are using these r and theta to describe the complex number, this point, then you say that you are using the polar form. And how are they related? So clearly this is a right triangle, and r is the hypotenuse of right triangle with legs a and b. So you get r square equals a square plus b square, which means r is square root of a square plus b square. And also tan theta is equal to b over a. So that means theta would be tan inverse of b over a. So that's how you can get the polar form from the rectangular form. You can get both r and theta. Now on the other hand, if you know the polar form, how can you get the rectangular form? So notice that if I know r and theta, then I can write cos theta equals a over r. Cos is adjacent over hypotenuse, and sin theta equals b over r. So now I have, to get a and b, I can multiply both sides by r. So a is r cos theta and b is r sin theta. So this is how I can go from polar to rectangular coordinates. From rectangular to polar and polar to rectangular. Now this idea is used in physics, for example. If this represents a force, an inclined force, and you're trying to split it into horizontal and vertical component, then you see that the horizontal component is r times cos theta and the vertical component is r times sin theta. So that's one reason why we want to have both polar and rectangular form of complex number. Another thing you notice is if you have on the unit circle, if you take any two complex numbers, so on the unit circle, if you multiply any two complex numbers, then their product will be another complex number on the unit circle. So this is a unit circle, its radius is 1. So that's the advantage. The polar form makes multiplication of complex numbers extremely easy. With rectangular form, you would have to write as two binomials and multiply, but polar form makes it so much easier. And we will have a separate video for just multiplication of complex numbers on the unit circle, and then we can extend it to multiplication of any two complex numbers. We see that the polar form makes it so much more simple